Welcome back. This is Mr. Hassan's Maths channel, and I've been requested to answer questions from this exercise, question number 8, A and C. Okay, and I'm going to actually answer question B first, actually. In fact, I'll probably answer all of these questions in this little video just to make sure that the question understands exactly what to do. So here we're asked to solve the following equations in the intervals given in brackets. Now, for B and D, it's kind of a bit more straightforward. So I'll start with those because there's a negative sign between them, and I'll explain why it's more straightforward in as I go through it. So let's start with B. Let's start with B. So here we have to solve 2 cosine 3 theta minus 3 sine 3 theta equals minus 1 in the interval from 0 to 90 degrees. Okay, so why is it that I'm saying it's more straightforward for us to do this one? Well, the reason being is because you have here a minus sign between them. Now, first of all, when we solve in an equation like this, we have two different ratios here with the same angle, 3 theta, the same angle, but two different ratios, sine and cosine and sine, or sine and cosine. Then if it says equals 0, for example, if this equals 0, then the way to do it, or an easier way to do it, would be to just basically divide everything by cosine 3 theta in order to make this into tan 3 theta. So you'd end up with 2 minus 3 tan 3 theta equals 0. You divide this by cosine 3 theta, it'll stay 0. And then you'll have a simple equation to set up. You'll end up with tan 3 theta is equal to 2 over 3. And then you can solve that quite easily in the limits, and you have to, of course, adjust your limits for the your interval to incorporate the 3 theta. But that becomes quite straightforward. But if there's a constant there, then you cannot use that method. You cannot do that, because when you're dividing everything by cosine 3 theta, you'll end up with minus 1 over cosine 3 theta and tan 3 theta, and it won't be as straightforward. Okay, so one of the methods that we can use using the double angle formulae is to rewrite this in the form of r, and then you have, there's different things you can write. Sine theta plus or minus alpha, in this case it will be 3 theta, or r cosine 3 theta plus or minus alpha. Now you have to decide which form fits with this particular question. Okay, and what we can do is we can bring up the double angle formula, which I think I have here. Yeah, these are the double angle formula from our formula book, and you can see which of these patterns fit this question. Okay, it's not the double angle formula, so it's the addition formula. That's what I meant to say. Right, so we can rewrite this into something of this form. So we're going to take our 2 cosine of 3 theta minus 3 sine of 3 theta, and we're going to write it in the form of r times, then we've got to decide what fits this. Now, if you look here, you're going to have a cosine on this side and a sine on that side, right? So we want the a, we want in this case, the 3 theta is going to be our a, and our 3 theta is going to be the a, okay, and our alpha is going to be the b. So it should be cosine a on this side and sine a on this side. So cosine 3 theta, so it's going to be this form here. Cosine a cosine b, sine a sine b. So we're going to use this, but we have to have a minus between them. It has to be a minus between them. So we can see here that the minus between them comes when you have cosine a plus b. So it's going to be r cosine of 3 theta, okay, plus alpha. So I can rewrite this in this form, and then I'll be able to solve the equation, equate this to -1, and then get our solutions. All right. Now, there's not really any, kind of like where you can rearrange. You can rearrange it, I guess, and put minus 3 sine theta plus 2 cosine theta, and then you'll have, the signs will be messed up or whatever, will be different. It will still work out, but this is quite obvious that this will split up into this form because we want to have cosine and minus and a sine, and that's the form that gives us that. Okay, so we could rewrite this now in this form and then go on to solve the equation. So now our objective is to find out what is r and what is alpha. Okay, if we can find out what r and alpha is, we can then solve the equation. So how do we do that? Well, we write this in an expanded form like this. So it will be like r times cosine of 3 theta cosine of alpha. So r times cosine of 3 theta times cosine of alpha. And you have minus the sine, r times, sorry, you've got the r's multiplying all of it, so the r will multiply both of them. Okay, so you'll have r times the sine of 3 theta times the sine of alpha. Okay, so that's what this is equal to. 2 cosine 3 theta minus 3 sine 3 theta is equal to this. Now we can use comparing coefficients to figure out what r and what alpha is. So for example, if I look at the coefficient here of 3 theta and the coefficient here of cosine 3 theta, sorry, of cosine 3 theta and cosine 3 theta, on this side I have 2. On this side, what's multiplying the cosine 3 theta? Well, it's r cosine alpha. And if I consider the coefficients of sine 3 theta on this side and on this side, I can see what are the coefficients of sine 3 theta on this side? Well, it's 3. And the coefficient of sine 3 theta on this side, well, it's r times sine alpha. So from this, I can now work out what alpha and r are. There's different ways of doing it. For this question, I'll show you the triangle way. For the next question, I'll show you the way involving squaring. But personally, I prefer this triangle method. So you make a little sketch of a random right angle triangle. Okay, and we can see here that I'm just going to adjust it so it looks a bit more realistic according to those numbers. You don't have to, this is just for the sake of the video, but if you have to draw any random right angle triangle, that's fine. It doesn't make any difference if it's realistic or not. But I'm going to call this alpha. And I know that according to this, cosine of alpha would be 2 over r. And the sine of alpha would be 3 over r. So if the cosine of alpha is 2 over r, this would be the adjacent, this would be the hypotenuse. And the sine of alpha would be 3 over r, this would be the opposite, this would be the hypotenuse. Okay, so here we have a right angle triangle. And if we know that by Pythagoras, r is the hypotenuse, so r squared equals 2 squared plus 3 squared. So therefore r is equal to the square root of, that's 4 plus 9, which is 13. So r is root 13. Okay, that's in its exact form. And that's where I want to keep it for now. And we can work out what alpha is very simply by just using trigonometry. We can say the tangent of alpha is equal to 3 over 2. Therefore, alpha is equal to, now we need to work in degrees, as we can see from the question. We've got degrees in our calculator in degree mode. So we just put inverse tan of 3 over 2. Okay, inverse tan of 3 over 2. And that will give us our angle, which is 56.3099. 56.3099 degrees. I can leave it in this more exact form for now because we're going to, in the end, solve our equation. Okay, so therefore we can say that 2 cosine of 3 theta minus 3 of sine 3 theta is equivalent to root 13, okay, cosine of 3 theta plus 56.3099 degrees. Okay, so now we can go on to solve our actual equation. We have to equate this to -1. So we can say, therefore, the square root of 13 cosine of 3 theta, the compound angle 3 theta plus 56.3099 is equal to -1. Now our theta is between. Now what this means here, this is basically another way of writing a limit. I'll say it's the interval. This is an interval. It's not like a coordinate, it's an interval. What it means is that's the lower limit, and you have 0 is less than or equal to, in this case it's going to be theta, which is less than or equal to 90 degrees. This is our limit, okay, for theta. All right. So that's what this means. Okay, if it was a curved bracket, you wouldn't have the equal sign. If it's a square bracket, you have the equal sign. That's all that means. So our limit is between 0 and 90 degrees. So our limits are between 0 degrees and 90 degrees included. Now, we have to change the limit according to this compound angle. So we have 3 theta plus 56.3099. And what we have to do is we have to just, whatever's done to the theta is done to these two limits. So this is 0, 3 times 0 is 0. So you have to start, the first angle must be from 56.3099. And our upper limit is 90 times 3, which is 270, plus 56.0. So it's 270, that's going to be 300 and I think 26.3099. Let's just confirm that in case I made a silly mistake. So 90 times 3 and plus the last answer, the 326.3099. That's correct. Okay. So those are our limits that we have to start and stop at when we are getting the answers for this. But first of all, of course, I have to divide by root 13. So cosine of 3 theta plus 56.3099 is equal to negative 1 over root 13. So the first angle is found by using the calculator. So we have 3 theta plus 56.3099 equals. So in my calculator, I'm going to put inverse cosine of negative 1 over root 13. Now that will give us our what's called the principal solution, which should be somewhere between 180 and 360 in the second, between 90 and will be in where cosine is negative. So it's going to be somewhere over here, yes, between 90 and 180. It's going to be 106.1. So that's 106.102. That's our principal solution, which is in our range. Now, the other solution for this is going to be in this quadrant here. You can think about it in the cosine curve. It looks like this between 0 and 360. Okay, so the other solution is going to be somewhere in this part here. It's going to be 360 minus this angle. Okay, 360 minus, that's the first angle. The other angle is going to be this angle over here, which is basically 360 minus this angle, because that is the same as that. So it's 360 minus the angle given. Okay, so we have 360 minus the answer. That gives us 253.898. 253.898 degrees. That's the second angle. Both of these are in the range. I don't think there's any other angles in the range. If I add 360 to this, it's going to be out of the range. If I take away 360 from this, it's going to be outside of the range. So those are the two solutions in our range, and those are what we will use to find our answers. So now I've got theta, then therefore will be 106.102 minus 56.3099 over 3, and also 253.898 minus 56.3099 over 3. So those will be our two solutions. So what I'm going to do is I'm going to store this angle as A. That will be this one. And I'm going to store this angle as B. That's okay. Hold on. Yep. That's B. And I want to store this as A, actually. Okay, so I'll store this as A. That's better. Okay, now, so I'm going to have, this is 56. Let's get this one as well, stored as C, just to make everything exact. Okay, I'm going to store this one as C. All right, so now this is C, and this is A, and this is B. Okay, so what I'm going to do now is I'm going to have, just so everything is exact now, I'm going to have this minus that. So just set it up. So I'm going to have A minus C over 3. So that's A minus c over 3. And that gives 16.597. 16.597. And then I'm going to have, I have to just change the A for B now. So this is going to be B now. Yep. And that gives us 65.863. 65.863. So therefore, it didn't tell us how to round the answer. So our answers will be 16.6 degrees and 65.9 degrees. Those are the two solutions for this question. Okay, and that's the method of going about answering them. Right, that's for B. Okay, now C follows a very similar type of pattern in terms of you have sine and minus cosine. So the A is what I want to have as sine, and the B is what and the A, the A is what I have to have as x over 2. All right, so this is going to be sine and then minus cosine. So you can see from this, it's going to take the form sine A minus B. So this will be rewritten in the form of r sine x over 2 minus alpha, and then you would follow the same procedure, okay, to find what r and alpha is and then solve it. And in this case, you'd have to, the limits are going to be between minus 180 and 180 in the end when you're gathering your answers. All right. So these two follow that very similar type of pattern. Okay. Now, as for A and C, here you have some sort of a choice. You could go by it as it looks here. You can say, okay, you want to have sine of A and cosine of A. So it's going to be like sine A plus B. All right. And for this one, cosine of A and sine of A. So you're going to have cosine first and then sine. So it's going to be cosine of A minus B. Okay, so you do the same thing for these. All right, although for these two, you have a bit more of a, you could write this as 8 cosine x plus 6 sine x. And you'll end up with a different r and a different alpha, but the solution to the equation will be the same because you will have a different ratio. So if I put 8 cosine x and then plus 6 sine x, then I'll have it in the form of cosine A minus B. All right, so there's different ways you can do it. So I'm going to show you how to do A in two different ways. Okay, in two different ways. The way it looks, and then the way as if you reverse them, and show that you'll get the same answer anyway. Okay, so that's what I'm going to do. And that's the question I asked about A and C. So I'll show how to do A, and hopefully they will understand how to do C as well after what we've just gone through. Okay, so now I'm going to show you, as I said, how to do this question, A, in two different ways. Now, first of all, let's take it the way it looks. So we got 6 sine x plus 8 cosine x equals, now we want to rewrite this in a form of one of these. So you're going to have r. Now, as I mentioned, if we take it the way it is now, we'll just say, okay, we want the x refers to the angle A, because we're going to end up with r sine or cosine, and you have x plus or minus alpha. So you'll have either sine or cosine. All right. So the x refers to our the angle A in this formula. So we're going to have sine A and then cosine A after it. So we can see that we're going to have this formula here, and we'll use the sine of A plus B. A plus B. So we're going to have here in this case x plus alpha. Okay. So the alpha is just what the angle is going to be in this place, which we have to find its value of, as is r is that coefficient here, which we have to find the value of. Now, I'm going to write this out in its expanded form like this. So I have r sine x times cosine of alpha plus r cosine of x and sine of alpha. Okay, so that's how I've written it down there, just looking at this pattern. Now I'm going to compare the coefficients on both sides of this, you can say, this identity. Okay, so I'm going to look at the coefficients of sine x, and also I'm going to look at the coefficients of cosine x and compare them to help us find r and alpha. All right, so if we look at sine x, the coefficient of sine x is 6. on this side. On this side, it's r cosine alpha, because if these are identical, if these two are identical, then the coefficients of all the variables must be the same. R and cosine alpha are fixed values which we have to find. So the number of sine x's on this side is 6. They must be the same as this. So r times cosine alpha must be the same as 6. Similarly, we can see that the cosine alpha has a coefficient of 8. So here the coefficient of cosine x has to also be 8. So the cosine x is 8 cosine x's on this side. There must be 8 cosine x's on that side, because these are identical. These are identities. So then I can say, therefore, that on this side you've got 8 equals r sine alpha. Okay, so we can do this in two different ways, as I mentioned. Okay, I can use the triangle way, or I can use some sort of way where we use kind of like squaring. So we could take this equation and we could square it, right? So this is equation 1, equation 2. If we take equation 1 and we square it, we end up with 36 equals r squared times cosine squared alpha. And if we square this one, we get 64 equals r squared times sine squared alpha. So you have r squared times sine squared alpha. So if I add these two equations together now, once they're squared, this gives me 36 plus 64, which is 100. This gives me r squared cosine squared alpha plus r squared times sine squared alpha. Now, r squared is common here. So you have r squared times cosine squared alpha plus sine squared alpha equals 100. And this gives you 1, because we know sine squared of an angle plus cosine squared of an angle is equal to 1. Therefore, we say r squared equals 100. Therefore, r equals 10. All right, so we know r is 10. And to find alpha, what we can do is we can take equation 2, divide by equation 1, because then we have sine over cosine, and the r's cancel out. So we have 8 over 6 equals sine alpha over cosine alpha, which is tan alpha, as we know from our identities. So therefore, we can find what alpha is by inverse tan of 8 over 6. So we do inverse tan of 8 over 6. And that will give us our answer, which is 53.130, 53.130 degrees. Okay, that's the angle. So therefore, what we can say then is 6 sine x plus 8 cosine x can be rewritten as r, which is 10 times the sine of x plus 53.130 degrees. And now we can go on to solve the equation, because we've got to solve where it's equal to 5 root 3. So we can say, therefore, the solution to our equation will be when 10 times sine of x plus 53.130 is equal to 5 times root 3. That's the equation that we're solving between the limits of 0 and 360. So we got x between 0 and 360 degrees. Okay, so now the only adjustment needed is to add 53.13 to each of these. So that will tell us where to start and where to stop in our limit. So we have x plus 53.130. So 360 plus 53, I think that's 410, right? So 413, sorry. So 413.130. Again, let me just confirm that, just to make sure that I didn't make any silly mistake. 360 plus 413. That gives us, 41. So what am I talking about? Plus 53. Sorry about that. Plus 53.130. So plus 53. That gives, 413.130. That's fine. Okay, so those are our two limits that we start and stop when we're finding our angles. Now, of course, I have to divide by 10 first. So sine of x plus 53.130 is equal to, when you divide by 10, that gives you root 3 over 2, right? Because the 5 and the 10 cancel. That's going to be root 3 over 2. Now, we should know from our exact angles that the sine of 60 degrees is root 3 over 2. So we can say, therefore, x plus 53.130 is equal to 60 degrees, which is within our limits. And for the sine curve, the other angles are 180 minus this angle, okay, as we can tell from the sine curve itself. This is our first angle. The other angle is over here, and this is 60 degrees here. So this must be 180 minus 60 degrees. So that's going to be 120 degrees. And are there any other angles in the range? Well, if we add 360 to those two, we can find that. So if we add 360 to the first angle, that gives us 420. That's out of the range, right? It's out of the range. And if, of course, I added to this, out of the range. So yeah, those are the two angles in our range. So therefore, we can find our solutions by just adding 53.130 to these two. So you have x equals 60 plus 53.130. That's going to give us 113.130. Let's just we've got to subtract this. What am I talking about? You're going to have 60 minus 53.130. You have to subtract from both sides, of course. And 120 minus 53.130. Not add. Okay, so we got 60. Let me just do something. Let's get that answer exact. Okay. Equals, so this is our answer. So 60 minus answer gives us 6.869. And we have 120. Let's go back to this again. 120 minus the answer gives us 66.869. 66.869. All right, so therefore, of course, our answers in degrees should be to one decimal place. So we can say x equals 6.9 degrees and 66.9 degrees. All right, so that's the solution to this in that method that we use. Now, as I mentioned, there is another method that we can use in this particular case, which is perfectly fine. I mean, for example, we could have written this down first. It could have been given to us as 8 cosine x plus 6 sine x. And if we were to look at this, pattern, then it would kind of fit cosine A minus B, okay? Because it's like cosine and then sine. So you could write it as r cosine of x minus alpha. And I'll show you how the r and alpha won't be this. Well, the r might be the same, but the alpha will probably be different in these two cases, right? But the answer should be the same in the end for our value of x in this equation. So let's just show how that works. So in this case, I'm going to rewrite this 8 cosine x plus 6 sine x. And I'm going to expand this. You have r cosine x cosine alpha plus, because if there's a minus here, you get a plus, and then you have r sine x sine alpha. And again, comparing the coefficients. So here you have 8 equals, and you're going to have cosine r cosine alpha. And on this side, you're going to have 6 equals, the coefficient of sine x is r sine alpha. Okay, if we use our triangle, we use our triangle, make it like a bit neater. So we're going to have, it's a bit thicker, doesn't matter. Okay, so we're going to have alpha over here. We say cosine alpha is 8 over r. Okay, so this will be 8 and this will be r. And sine alpha is 6 over r. So this is going to be 6 here, right? Sine alpha is opposite over hypotenuse. As I said, if you rearrange this, you get cosine alpha. Cosine of alpha is equal to 8 over r. And the sine of alpha is equal to 6 over r. Okay, it doesn't have to be realistic, that's fine. So now we can say r is equal to the square root of, by Pythagoras, 6 squared plus 8 squared. That's 36 plus 64, square root of, that's 100. Square root of 100 is 10. So r equals 10, as we found earlier. All right, but alpha will probably be different. And we know that tan alpha here is equal to opposite over adjacent, so it's 6 over 8. So therefore, alpha is equal to inverse tan of 6 over 8. So it will be a different answer for the value of alpha, but the final answer, the solutions to the equation, should be exactly the same. So that gives us 36.869, 36.870, I'll put 36.870, 36.870, but I'm going to just store this as a calculator. All right, so that's alpha. So therefore we can say that 8 cosine x plus 6 sine x is equivalent to 10 times the cosine, this time, of x minus 36.870. And then we can use this to solve the equation. So we can say here, if we want to solve this equation, we can say that, therefore, 10 cosine of x minus 36.870 is equal to 5 root 3. Okay, 5 root 3, wasn't it? Yes. So therefore we can say the cosine of x minus 36.870 is equal to, you divide by 10, you're going to have root 3 over 2. And we know that the cosine of 30 degrees is root 3 over 2. So we have our limits, the same limits is from 0 to 360. Okay, so you have from 0 to 360 for x. So therefore we have to subtract this time 36.870. So you're going from minus 36.870 up to, and this is going to be 360 minus, so 360 minus that, which is going to be 323.130. 323.130. Okay, so now those are our limits. So the first answer we get, x minus 36.870 equals, as I said, 30 degrees. That's within our range. Okay, and then we have the other angle is 360 minus this, which is outside of our range. Okay, so I'm going to write that down. That's 330. That's outside of our range. For the cosine curve, you have this situation here, right? So the first angle we got was over here. That's 30. The other angle is over there, which is 330, which is outside of our range. However, the cosine curve also goes, of course, they will all go into the negative side. There's another angle here, which is negative 30. The positive angles are always replicated on the negative side because the cosine curve is symmetrical about the y-axis. So there's also an angle minus 30 degrees, which is in our range. So our two main solutions that we're going to use to find our answers are these two. We have 30 and minus 30 we can use. All right? This one is rejected because it's outside of our range. Okay, so the two main angles are 30 and 330, and then all the other solutions are 360 away from them because the curve repeats every 360 degrees. So the next angle from this will be 390, which is outside of the range. The next angle from this, of course, on that side will be way out of the range. But before these two, 360, 30 minus 360 is minus 330, and 330 minus 360 is minus 30. And minus 30 is in our range, okay, because our range goes back to minus 36.870. So therefore, x is going to be 30 plus 36.870, which gives us 66.870, and x equals minus 30 plus 36.870, which gives us 6.870, and those are exactly the same two answers that we got, 66.9 and 6.9 to one decimal place, as you should give answers to degrees unless otherwise stated. So you can see we got exactly the same two answers. Okay, exactly the same two answers, whether we wrote them in this form or we wrote them in this form with sign. Okay, so you could switch them around if you want to, especially when they're both positive. If one of them is negative, then it's best to keep it in the way that we did in the last question. But that's just a little summary of how to deal with such questions. And normally I would just go by the way it's given, right? And in most of these questions, a lot of the questions you have, first part of the question is asking you to write this in one of those forms. They'll ask you to write it in a particular form that they give you and then solve the equation. So it's pretty straightforward. But if they give you a question like this and they don't tell you to do that first, you should understand if it doesn't say equals 0, then this is one of the methods, probably the easiest method for you to use to solve it. If it says equals 0, then you can just divide by cosine x and you end up with an equation with tan in it. But if it doesn't say equals 0, then you have to combine these into one ratio in this way or the way that I showed. It's normally best to just follow the way it's written down, but I showed you how it works either way. Right, so it's just a little bit of explanation. Hopefully the student who asked the questions from this exercise understands what to do now for the rest of those questions. I think they asked for A and C, so I've answered, I think, B and A. So hopefully they can do C by themselves now after this explanation. If not, then they can, of course, send me a message and I will help them further if needed. So anyway, so that concludes this video. Other questions that are from this particular chapter of this textbook can be found in the playlist over here. So that's P3 chapter 4. All the questions I've answered from that textbook will be in the playlist appearing in this section over here. Other questions from the P3 topic of trig identities and equations can be found. In fact, the trig addition formulae, whatever, identities and equations can be found in this playlist over here. You can subscribe to my channel by clicking on this link, and you can watch the video here, which will linked over there, which will teach you how to use my channel in an efficient manner. Thank you for watching, and see you soon.